Hi, and welcome back. In this video, we look at the types of search algorithms used for solving problems in AI. Basically, there are two types of search algorithms in AI, which are the uninformed search algorithm and the informed search algorithm. In this video, we'll focus on the uninformed search algorithm. And for the uninformed search algorithm, there are actually 6 types that exist. But for the scope of this video, we'll focus on the two most important ones, which is the depth-first search and the breadth-first search. But first, let's play a game, a simple maze game. And the purpose of this game is to move from an initial state A to a goal state B by taking some sequence of actions. Now, you must note that the empty squares are our state space, or all the states reachable from the initial state, so to speak. And the filled ones are some sort of boundaries. If these terms seem unfamiliar to you, you might want to watch the previous videos to get a sense of what you're talking about. So using the depth-first search algorithm to play a game like this one, what will an AI do? The AI will just follow one path. If it reaches a fork in the road where it has multiple different options, depth-first search, or DFS, is going to choose one, and we'll explain how it makes this decision in a moment. So it's just going to choose one, but it's going to keep following one until it hits a dead end. And when it reaches a dead end, DFS effectively goes back to the last decision point and tries the other path, fully exhausting the entire path. And when it realizes that, okay, the goal is not here, then it turns its attention to this path. It goes as deep as possible, and when it hits another dead end, it backs up and tries the other path as well. So it keeps going as deep as possible than one particular path, and when it realizes that that's a dead end, then it will back up and ultimately find its way to the goal. While DFS took one path and kept following it, BFS, on the other hand, is going to follow a path until it reaches a decision point and explore both. So it's going to look at this node and that node and the other, and so on and so forth. And when it reaches a decision point again, rather than pick one left and follow it, it will again explore both, alternating between them, going deeper and deeper, until ultimately we make our way to the goal. And what you see is while BFS took us from A to B by exploring different paths kind of at the same time, it's needed to explore a lot of states in order to do that. And so the trade-off you see here between DFS and BFS is that in depth-breadth search, there's some kind of memory saving as compared to breadth-first search, which explores all the states and kind of exhausts memory. But that will not always be the case. Now, let's take a look at a more technical point of view using graphs where we want to find a path from A to E. And this represents the exact same idea. A node is a state, and the edges represent actions, that is, left, right, up, or down. So the AI follows a path until it reaches a decision point. And now comes the question of how the AI decides whether to choose between two or more states, which we'll put in a box called frontier, which basically contains our decision states. And here we introduce the idea of a data structure called stack, which is a last in, first out data type, which means the last thing that I add to the frontier is going to be the first thing that I remove from the frontier and explore. So now we start with A, which is our initial state. And where can we go from A? We can actually go to B. But B is not what we are looking for actually. We are actually looking for E. So we need to make more exploration. So where can we move on from B? Okay, from B we can either go to C or D. But we are using stack, which means we will first explore the node or state that came in last, which is D. So we move to D. At D, where can we move on to next? We can move to F. And now we've reached a dead end, which is the deepest we can go. And now, what is the last node that came into our frontier? Well, that is C, which is even the only possible node in our frontier. So where can we move on from C? We can move to E. And now we've reached our goal or solution. Now we have realized that we took a path, followed that path until we hit a dead end, back up to the last decision point, and chose a different path which is very similar to our depth-first search based problem. Now let's move on to the breadth-first search, which is quite similar, except that we use a data structure called Q, which is a first in, first out data type. What this means is that the first node that we add to our frontier is the first node that we explore. So like depth first search, we start from A, move to B, and now we have a decision point which is C and D. But here we are using a queue data structure. So the first node that we add is the first node that we are going to explore, which is C. So from C, where can we move to? We can move to E. But E came to meet D in the frontier, which means we move to the first node we added, which is D. And from D, where can we move on to next? We can move to F. But F came to meet E in the frontier. So we'll explore E first. And now we've reached our solution, which is E. Unlike our maze problem, you can see that BFS or breadth first search goes back and forth between states and explores the states at sort of the same time until it reaches its goal. So to recap, depth first search follows a path, and if it's come to where a fork or decision point is, it uses a data structure called stack to choose between them and goes as deep as possible until it reaches a dead end, and then backs up to the last decision point and chooses another state, explores as deep as possible, and on and on. On the other hand, breadth first search follows a path, and when it comes to a fork or a decision point, it explores all the decision points all at once at the same time. In the next video, we'll look at the other type of search algorithm called informed search. Thanks for watching.